Now question number 11. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. 1 to 20 numbers are there. 6 numbers are to be chosen. And if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? So we have 6 natural numbers has to be chosen from out of 20. So this can be done 26 different ways. Okay. Now total number of ways is 26. And a person wins the prize when already 6 numbers are fixed and the chosen number is matching with these numbers, then that person will win the lottery. So how many matches are possible? Since there is only one choice which will match, then total number is 1. 1 out of 26. 1 by 26. So this is the probability of winning the lottery. Okay, that is 11th question. 12th question is, check whether the following probabilities P of A and P of B are consistently defined. Whether consistently these probabilities are defined or not. So probability of how we check probability the consistency 0.5. Probability of B is equal to 0.7. And what about probability of A intersection B? A intersection B is equal to 0.6. And here you can observe one thing. A is bigger set than A intersection B. You know, whenever A and B are there, this is A and this is B, and this small portion is A intersection B. And this small portion is always less than or smaller than this bigger portion. So probability of A intersection B is a smaller quantity, less than probability of A. So this is quite evident. Probability of A intersection B must be less than probability of A. Is it true in this case? Probability of A intersection B 0.6 and this one is 0.5. That is wrong. Okay, therefore it is not consistently defined. It is not correctly defined. That is the meaning. And in the second case, probability of A union B is equal to probability of A plus probability of, see what are given. Probability of A is given, probability of B is given, probability of A intersection B is given. Okay, now let us check the probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B is equal to 0.8 and probability of A is 0.5 and probability of B is 0.4 minus probability of A intersection B is not given. Okay, so probability of A and which is possible. So probability of A intersection B we don't know. Probability of A intersection B is a substitute here, and 0.8 equal to 0.5 plus 0.4 0.9 minus this must be 0.1. So 0.1 is a possible value of probability of A intersection B. Therefore it is correctly defined. So that is the answer. And similarly the next question, see what is given. Next question number 30. So here again what you have to do is fill in the blanks and see using this formula, probability of A plus probability of B minus probability of A intersection B is equal to probability of A union B. Using this formula you can find out So this is the formula, probability of A plus probability of B minus probability of A intersection B. These values are given. So probability of A plus probability of B minus probability of A intersection B is equal to probability of A union B. This is the formula, and using this formula whether this matches or not, or you can find out the unknown quantity. Probability of A union B you need. So this quantity you want A union B. The all other quantities are given. 1 by 3 plus 1 by 5 minus 1 by 15. 1 by 3 means 5 by 15 plus 3 by 5 minus 3 by 15 minus 1 by 15 is equal to 5 plus 3 8 minus 1 7 by 15 is the answer. 7 by 15. In the similar fashion 7 by 15, that is probability of A union B. Similarly, one quantity is not given, that quantity you can find out. Now given probability of 14, question number 14 is given probability of A is equal to 3 by 5, probability of B is equal to 1 by 5, find probability of A or B if A and B are mutually exclusive. So here you have to find out probability of A or B means A union B, and A and B are mutually exclusive events. Mutually exclusive event means probability of A intersection B is equal to 0. So use this formula, probability of A, probability of B minus probability of A intersection B is equal to 0. So probability of A union B you will get, you find it out. Now question number 15. Question number 15, you have to find out probability if E and F are even such that probability of E is equal to 1 by 4, probability of F is equal to 1 by 2, and probability of E and F, that means probability of E intersection F equal to 1 by 8. Find probability of E union F. Find the probability of E union F. That you can find out, and as I said in the previous case, using that formula you can find out. Now second one is, what is the value of probability of not E or not F or not F complement? Okay, how do we find it out? Actually this is probability of E intersection F whole complement using the De Morgan's law. Okay, and what is given? E and F are probability of not E and not F. So this quantity you have to find out. E or F you can find out. Okay, and this is equal to probability of a set complement is 1 minus probability of E intersection F. 1 minus probability of E intersection intersection. Actually you want to find out and, sorry, here it is and given. I have made a mistake here, and is required. So here it becomes union. So here it becomes union. So in the first step you will get probability of E union F. Probability of E union F you will get. Okay, and that quantity you subtract, then you will get this. Actually it is and. I am confused with this question. Now in this question what is given? Probability of, that also I will explain, not E or, here it is or F complement, here it was given and. Okay, that is equal to 0.25. So what is this probability of E intersection F whole complement, okay, is equal to 0.25, is equal to 0.25. What is it? 1 minus probability of E intersection F. 1 minus probability of E intersection F is equal to 0.25. probability of E intersection F is 1 minus 0.25 equal to 0.75. 0.75. So whether E and F are mutually exclusive or not, that we have to check. No, it is not mutually exclusive because the answer is 0.75. If it is 0, then you can say that it is mutually exclusive. Okay, now we go for question number 17. A and B are even such that probability of A is given, probability of B is given, probability of A and B is given, then determine probability of not A. See, these questions are very important. Probability of not A. Not A. Not A means A complement equal to 1 minus probability of A. 1 minus probability of A is given, 1 minus 0.42, that is equal to 0.58. Okay, answer is 0.58. Second one is probability of not B, similar way. Not B means probability of B complement, 1 minus probability of B. You subtract probability of B. So 1 minus 0.48 means 0.52 will be the answer. Okay. PA or B, probability of A or B means A union B. Use the formula probability of A plus probability of B minus probability of A intersection B. A intersection B is given. A intersection B is also given. A and B, that is A intersection B. So all these quantities are readily available there. You substitute and find the value. Question number 18. In class 11th of a school, 40% of students study mathematics. Maths, probability of maths 40 by 100. Okay. Mathematics 30 study biology, probability of biology is 30 by 100. And 10% of study both maths and probability of maths intersection biology, both 10 by 100. That is the meaning of 10 by. If a student is selected at random, find the probability that he will be studying mathematics or biology. That means you have to find out probability of maths union, maths or biology means this one. And the formula 40 by 100 plus 30 by 100 minus 10 by 100. 70, 60 by 100 is the answer. 60 by 100 or 0.6. Okay, so that is quite easy and very important also. In an entrance examination, wait, we have to, one more question is there. What is that? In an entrance examination, see what are given. So quite simple, as we did before. In an entrance examination that is graded on the basis of two examinations, the probability of randomly chosen student passing the first examination is probability of first examination is 0.8. Probability of the passing the second examination, probability of I write second examination is 0.7. The probability of passing at least one of them is probability of passing at least one of them. Probability of passing at least one of them means probability of first or second is equal to probability of passing at least one of them is 0.595. That is what is given. What is the probability of passing both? So we have to find out probability of passing this one. So very easy. Probability of F union S is equal to probability of F union S is equal to probability of F plus probability of S minus probability of F intersection S. This value we have to find out, and all other quantities are given. 0.95 equal to 0.8 plus 0.7, and this we don't know. Probability of F intersection C. This you bring it here, and probability of F intersection C becomes 0.8 plus 0.7 is 1.5 minus 0.95, which is equal to 5 plus 5 0 0.55 will be the answer. Okay. Now question number 20. Question number 20 is the probability that a student will pass in the examination in both English and Hindi is. So that is again the same way. Probability of student will pass the final examination in both English and Hindi. In both English and Hindi. Both English and Hindi. Both English and Hindi is equal to 0.5. Passing neither is probability of nor English. Nor English. Neither English nor Hindi. That is what is 0.1. If the probability of passing the English examination is 0.75, probability of English is 0.75. What is the probability? What is probability of Hindi? This is what we have to find out. And here it is given that probability of, as in the previous case, E union H whole complement is equal to 0.1, from which we get the probability of E union H complement is equal to 0.1. That means probability of E union H is equal to 0.9. So answer is given, probability of E intersection H is given, E union H is given, and probability of E is given. So what is probability of H? Probability of H plus probability of E minus probability of E intersection H is the quantity probability of E union H. E union H is 0.9. Probability of H is, we don't know, equal to probability of E 0.75 minus 0.5 plus 0.75 minus 0.5 is equal to 0.25. Okay, 0.25, and P of H is 0.9 minus 0.25. You just calculate. So that you will be getting 5.65 is the answer. And that is the end of 20 questions. I think let us check. One more last question is also there. And after that, miscellaneous section, those questions you can check it out. In a class of 60 students, 30 opted NCC. See, this question is also similar way, and you can solve probability of NCC, probability of NSS. 32 opted, that means 32 by 60. 24 opted, 30 opted NCC, 30. 32 opted NSS, and 24 opted both. 24. So what? So the student opted NCC or NSS. That means probability of NCC or NSS. You know the formula, probability of N plus probability of S minus probability of N intersection is 30 plus 32. 30 plus 32 minus 24 by 60. So that you calculate. And similarly, neither student has opted neither NCC nor NSS. So you have to find out probability of neither, number of this one is equal to 30 plus 32 minus 24, 38 will be the answer. 38 by 60. Probability of neither nor means probability of an intersection S, and that is equal to probability of n union S whole complement, that is equal to 1 minus probability of n union S. So that 1 minus 38 by 60. 60 minus 38, that is 24. 32 minus 60 minus 38, 22 by 60 is the answer. Similarly, the student has opted NSS but not. That means probability, this one, probability of opted NSS, that means S, probability of S and NSS but not NCC. And that is equal to probability of S minus probability of S intersection N. This formula you just see. Probability of S 32 by 60 minus probability of S intersection N 24. That is equal to 8 by 60 is the answer, or 4 by 50. So that is the end of the section. Thank you.